Hi everyone, and welcome at another episode of AI Talks. This week we're having Derek over, and he will be talking about Azure Search and all the new features that was announced during Microsoft Ignite just the other day. So all happy to have you here.
Hey, my name's Akansha Malik, and I'm from Melbourne.
Excellent Somi with Val here.
Hi, I'm Alan Smith.
Hi, I'm Amy.
Hey, Neighbor Tess. I come from Spain.
I'm Prasant from California.
大家好，我是卢建辉。
I'm Fakasi from Australia.
Hi, I'm Jennifer Marsman from the United States.
Hi, I'm Akita Gupta from India.
Hi, I'm Matthew Renton from the USA.
I'm Joseph Isaac from California. Hi, Mehdi Ali Daoud from Ghana.
Hi, I'm Ana Famana.
Merhaba, ben Türkiye'den Daron Yönden.
Hi there. Hi. Hi.
Hi. Hi.
Hi.
Hi.
Hi, Derek. Welcome to the show.
Thanks for having me, Sammy. Happy to be here.
How are you doing?
Doing pretty well. It's been a exciting week with Microsoft Ignite. It's always a little bit like being a kid in the candy shop, hearing about all the cool things coming out.
Exactly. We have quite some nice announcements that came up for Azure AI. Not that much, but some really good ones. So we're happy about that. Derek, for the people who do not know you, who are you?
Sure. So my name is Derek Legenzoff, and I am a program manager for Azure Cognitive Search. So working kind of building out that search product, and in particular, I spend a lot of time working with customers and making sure our customers are able to be successful with the product.
Okay, cool. So today we're going to discuss some new features in Azure Search. For those who do not know what Azure Search is, can you explain it to us?
Yeah, do you mind if I share my screen? Got a couple slides to help explain.
Sure. Share the correct one, eh?
Yep, always important.
There you go.
So Azure Cognitive Search is a platform as a service. We sometimes call search as a service, and really what we are is a platform with the goal of making it as easy as possible to add a rich search experience into your application. Especially if your data is in Azure already, it can be just incredibly easy to make this data searchable. Within a few clicks in the portal, you can get data from SQL, Cosmos, or Blob into a search index. And then we have SDKs and APIs and other tools to allow you to kind of quickly integrate this into your application. And we have kind of all the different functionality you would expect in a search search engine. We've got kind of suggestions and autocomplete, filters and facets to help you refine your search results. We can rank those search results. Typical snippets and highlighting. Of course, pagination. There's geospatial queries you can do. And there's lots of kind of rich query syntax. Like a lot of customers will use fuzzy search or proximity search or regex search to kind of be able to refine and drill down to kind of exactly what you're looking for.
Cool. Yeah, for the ones who are hearing background noises, my little daughter is sitting next to me, so excuse me for that.
It's very cute.
Yeah, I'm personally a very big fan of the service. I'm using it quite often at our customers. It has some very nice features, some hidden, some are like there in your face, and that's really cool. So today you want to talk about the new features, and I'll just give you the platform.
Sounds good. Exactly. So you might have seen at Ignite kind of our big announcement around Semantic Search, which will be kind of the main thing I'm talking about today. But to kind of, I guess, put this in perspective, if you look at cognitive search's value proposition, the first thing is that we're fully managed, and we want you to spend your time focusing on building a great search experience rather than having to manage the search cluster. So we make it really easy. You can go to the portal, scale partitions to be able to support more data, kind of add additional replicas, and we just want to make that as seamless as possible. And then kind of course, we have all this built-in AI, and we started this journey a few years ago with helping to make unsearchable data searchable. And I'll walk through that a bit today as well. And we're platforms, so we're fully customizable, and then we're secure and compliant as well. So we have kind of all those security features you would expect in Azure Search, in a typical kind of Azure product. And you have compliance is like we're HIPAA compliant, so you can use this with healthcare customers and all that great stuff. But this is the global AI community. So really want to kind of focus in on this bubble today around kind of built-in AI and really kind of the value we can add there. And as I kind of briefly mentioned, a couple years ago we started this journey, and the goal was really to kind of make unsearchable content searchable. And to do that, we really infused AI at the indexing side. So as you're ingesting content into a search index, where you are able to kind of infuse AI to enrich your content and make it more searchable. And it's kind of, you walk through this process of being able to crack open documents, add in additional enrichments via cognitive services or your own custom skills. And then ultimately, you're landing all this data in an inverted index. So you're then able to kind of quickly retrieve documents and have efficient search for query time. But up until this announcement at query time, we've still been we've been following kind of the industry standard of BM25 and looking at syntactic similarity. But there's I guess a lot of potential is how we can add AI into the query side of things to make search better. So I'm excited to kind of show you these as I kind of move on with this presentation. But first I wanted to spend just a few minutes kind of walking everybody through the indexing side and how we use AI at indexing. And where this really started is you take a look at this picture. I'd say most people these days don't have rooms like this, but I think we all have the digital equivalent of this, where there's all this content, and to really make it to really be able to use it and find what you're looking for, it sometimes takes a little bit of work to kind of get that content out of there. It's kind of like they say, data is the new oil. Needs to be refined and kind of structure given to it. And so what we did is we kind of created this ingest, enrich, explore pattern for cognitive search to really enable you to take these this unstructured data and make use of it. And about 80% of business relevant information is unstructured. So it's kind of there's all this sort of content that if we had at our fingertips, we'd be much more efficient with our jobs or other works. And there's some like crazy stats out there about the amount of time knowledge workers spend you're looking for the content they need, and how much money could be saved. So the more we can do to make content easily accessible to people, the better. So to kind of quickly walk you through this ingest, enrich, explore pattern, and I will kind of show a quick demo in the portal. The first thing is, so to be using skill sets, you need to have your data on Azure somewhere. For example, let's assume we have a collection of PDFs that we want to make searchable and add a search experience to them into our application. So what we're going to start with is adding those PDFs to a data source. In this case, for physical documents, the most common data source is blob storage. We're going to then, as you're ingesting these documents in Search Index, we're first going to crack open these documents and pull out all the text, pull all the images, and then we're able to send those texts, send that text and those images through this extensible enrichment pipeline, where you're then able to use various kind of AI skills to enrich your content. And ultimately, we're then going to land that data in the Search Index so that you search over it and find exactly what you're looking for. So now I just want to kind of drill down in kind of each of these sections quickly and show kind of a little bit more detail kind of what we're talking about. So the first stage is kind of this document cracking and getting all the information out of this content, out of these documents. So we support a variety of different data sources, and one big request we had is to support SharePoint as a data source. And so we're excited to announce as part of Ignite, we do have a SharePoint indexer in preview. So it's something you can now kind of take advantage of and test out if you want to be able to pull content from SharePoint. And we also did recently GA our Data Lake Gen 2 data store as well. But so with this, we support all these different data stores. I'd say these top three are the most common we see customers using, and particularly with physical documents, blob storage is a big one. And we support a variety of different file formats. This is just kind of the tip of the iceberg. There's additional file formats we support as well. And we actually have some customers, for example, in the oil and gas industry, you might have some very particular specific file formats that maybe they're not generalized enough for us to support, or there's some file formats that different applications might even have different formats for it. So it's difficult for us to support because there could be these different formats. But we've seen customers even build kind of a simple custom skill that allows them to kind of crack open that content and make that searchable as well. So really, we're able to really handle all sorts of different content because of this functionality. You can see, take an example like this PDF, we're able to extract out text, we can extract out its metadata, we pull out the images, and then now we have all this content at our fingertips that we can then kind of enrich in the next stage of this pipeline, which is this what we call the skill set, or sometimes the extensible enrichment pipeline. And also, we have all these different built-in skills you can use. Some of the ones I find myself using the most are optical character recognition to pull text out of images. Key phrase extraction is always a nice one as well. This custom entity lookup is also one of my favorites because maybe you're doing search for recipes and you want to be able to have people be able to filter by ingredients. You could build a machine learning model and train it to do entity recognition, but in a lot of cases, you might have like a pretty good list of ingredients at your fingertips. You can just give us that list, and you'll be able to use the custom entity lookup to extract out all those ingredients. Then all of a sudden, you can add a faster filter to be able to make that search experience more rich. There's various vision skills. Text translation is another one I think is super cool. If you have say you have all content in English, but you want your content to be searchable in 5 languages, as you're ingesting this content in the search index, you use that text translation skill and be able to make it searchable in all those different languages. And what makes this even more powerful, and why we keep using the word extensible, is that beyond just using these built-in skills, you can build your own skills, and these are really just kind of a REST API deployed with a specific input-output format. We see customers deploy Azure machine learning models or Azure functions that you can kind of quickly integrate. And really, what's really powerful is you can do whatever you want. I find myself doing little simple custom skills all the time, and they can really make the search experience more rich. But you can also kind of go and train really fancy machine learning models. Like we've had customers that train models to extract GDPR risks from contracts, or you extract risks in technical documents and stuff like that. So there's really kind of a lot you can do and really kind of build out a rich solution to make your content really searchable as you're indexing it. And with that, I want to show you kind of what this actually looks like in practice. So over in my web browser, I have a storage account I created, and I just uploaded 14 different PDFs into that storage account, and they're actually just PDFs that I more or less went to the Azure Docs, and I downloaded some of the Azure search content and downloaded it as a PDF. I could just show you that real quick. So we have these 14 different PDFs with a variety of text and image now in this blob storage account. And if I want to go and make this searchable, what I can do is I can go to my search service, and I'll go to this import data wizard. And I'm going to select my data source. You can see all the different new data sources that we support. So we'll select blob storage. I'm going to get this little wizard to allow me to go and find my blob storage among kind of all my other storage accounts. Go ahead and select this docs container I just showed you. We'll give this a name. We'll just call it docs. I already used that. So we'll put demo after it. So now we've created a data source. We're telling the search service, hey, here's the data that we want to ingest into the search index. You can see actually the portal did a little bit of wizardry here and is kind of looking at the schema of my documents, so it can infer an index schema for me down the line. And now I'm actually ready to add in all these AI enrichments. So first thing you do is you attach a cognitive service. You can use a free one for the first 20 documents. I only have 14 documents here, so in this case I'm okay to use just the free one here. And now I'm able to go here and add my my enrichments. We'll just give this a name. We'll call it the doc skill set. Hopefully I haven't used that. And now I can say, I want to enable OCR and merge all the text into this merge content field. And then I want to send that text to these various other cognitive skills. So in this case, there's probably maybe not very many people, organizations, or locations in my technical content, but I do want to extract out key phrases. Let's detect the language. And maybe I want to, let's translate this to Spanish. We'll go ahead and we can see the list of available languages. There's Spanish. And I can also apply various image cognitive skills as well. In this case, I'm already doing OCR, and I'm not sure for there's probably not images that are great for captioning in this data set, so I'll leave those off. With that, you told the search service that when I index this content, I want to leverage all these AI skills. And with that, we're ready to actually go ahead and customize our index. Give this a second to validate for us. And what's nice here is the portal is kind of going to give us a default, so we can see kind of all these different fields. So we see I've got my key phrase and language. So it's actually, I'm going to make these filterable and facettable so that I am able to have that fast on the kind of left side of the search bar. We see it's already selected the Spanish analyzer for my translated text, which is awesome. I do actually want to use the English analyzer for my merged content field. In this case, like if your content is consistently in a language, you're usually going to get better recall for your search results if you select a language analyzer. In this case, we'll use the Microsoft analyzer. And I've got this merged content field, so we'll just we don't need both the content and the merged content. The merged content actually has the text images in addition to the other texts.
Derek, can you explain why someone would use Lucene versus Microsoft Analyzer?
Sure. It's a great question, and I forget kind of the exact details off the top of my head. We do have a great kind of doc page that it explains it, but I wish I had this better memorized. But Sammy, I feel like you might know the answer to this one actually.
Well, no, not exactly, not in detail. I thought you would be able to give more details about it.
Yeah,
yeah,
so,
there's a difference. In
so the Microsoft Analyzer, I believe, like, so if I remember correctly, the Lucene Analyzer leverages kind of like stemming. So running will be stemmed to run, versus the Microsoft Analyzer is a bit more sophisticated, where it's using a lemmatization. So it's actually like, so more or less, it can potentially kind of view it and improve the recall further. But there's actually this really cool demo out there that a partner put together. It was Wild Mouse, I believe. And you can actually see kind of like a standard analyzer versus like the Lucene analyzer versus the Microsoft. And you're able to see the difference in recall between between the three. And actually, like, for example, if you search like thinking, the Microsoft Analyzer will be able to return the word thought, whereas like the Lucene Analyzer, that's not something that might necessarily be able to handle. The other benefit of the Microsoft Analyzer is it gives us a little bit of extra language support. So there's a few languages where we have a Microsoft Analyzer, but there's not an existing Lucene Analyzer. So it allows us to support a few additional languages.
Okay, cool.
So we've got that selected, and then this text here is actually going to be the text that's extracted from images. Normally you wouldn't need this, but just for demo purposes, I'm going to create that. So you're going to leave that in there. We'll go ahead and create my indexer. We'll just add a 2 in case I've already used that name, and we'll go ahead and submit that. And to this point, it's creating a data source, creating a skill set, creating an index, creating an indexer, creating all this stuff to be able to kind of seamlessly move the content from our data source to our search index. And within the portal, you guys go here, you can kind of monitor the progress. If you're anything like me, I tend to kind of sit here and hit refresh till it's finished, and I'll go explore my documents. The last time, I think it took about, there we go, it's already finished 23 seconds to process these 14 documents. You can actually click into this and see a little bit more information about the run. In this case, it looks like everything worked pretty well. I don't see any errors or warnings, which is always nice. And then now we can actually go to Search Explorer and then search against this content. So we've got my Azure blob index here, and we'll just select the first document. Just say top equals 1, just to look at the first document and see what that looks like. So you can see here we've got all the key phrases that have been extracted from the document. It looks like it's done a pretty good job. I mean, you've got C#, your query component language analyzer, kind of all these technical terms around search. If I scroll down a bit more past these key phrases, we see my translated text. We see all the content from the Microsoft Doc page in Spanish now. And then if I scroll down further, you can see kind of all the English content. And then this is actually, looks like there was 3 different images extracted from this document. 2 of them looks like they were named text. We actually were able to extract this text from the 3rd image. And this is kind of, I guess like a great value out of cognitive search that in this case, it's kind of a small amount of text that we're now making searchable, but without kind of this OCR component, we wouldn't have been able to search against this content. And I think there are kind of lots of documents and other sorts of content where you can really have a lot of content trapped within images. So OCR is kind of a great way to get that out. So that that is kind of the process of you're using AI at indexing time to enrich your content. You saw like kind of just how easy that is. And with that, I now want to talk about semantic search, and our goal is to make it just as easy to use semantic search as it is to use AI to enrich your content. And kind of going back to the slide, how I've just kind of walked through how we're able to use AI at indexing time, but equally important, or perhaps even more important, is be able to find exactly what you're looking for once this content is in your search index. And there's kind of this typical process for querying. So all this data is stored in the inverted index, where then we're gonna search terms such as how to build a better mousetrap. So for example, we're gonna look for every document that has the word mousetrap in it. We're gonna retrieve those. Then we're gonna use the BM25 algorithm to then rank those results, and ultimately we're gonna return those to you. But there's definitely an opportunity to make this more rich. Like Google and Bing provide just such like rich search experiences that it I feel like we're almost spoiled by the goodness they provide. And when we go to kind of the syntactic similarity, like sometimes you're like, oh, I thought I would be able to get that, and we had to kind of understand under the hood. Here's how search engines are really kind of working. And today, kind of the industry standard for search engine is keyword based ranking, and we've got this pretty fancy equation down here. But this is the BM25 algorithm. At the end of the day, it's really pretty simple. We're going to take a block of content like this. We're going to tokenize it using those analyzers, such as the language analyzers that we discussed, which is actually a really important topic in search. And then create this an inverted index, something similar to this, where we know, okay, this document had the word beat twice in it, had Waldo twice in it, and when someone's searching something, we're essentially asserting the relevance of a document based off of just the frequency of these terms. That's kind of really what BM25 boils down to. And going beyond that, in Azure Search, there's all sorts of different knobs that you can kind of play with, and things you can tune to alter your search relevance. And we actually even have a sample out there where you can log clickstream data, so you can log everything people search, what documents they've clicked into, and then you can build your own machine learning model to then be able to re-rank your content. And actually, that can work pretty well for a lot of people, although it is a lot of effort. You need a lot of data for that to be viable. So it's kind of a bit of that barrier to entry to kind of do something like that. But there are kind of simpler approaches as well, such as using your language analyzers, which will improve kind of recall, like we discussed briefly. You can do custom analyzers. So for example, there's a concept of like an n-gram, where you can use an n-gram analyzer to enable kind of partial term search. You can also do that with query syntax. But it's a great way you can kind of improve your search results and recall. You can add scoring profiles. You can use different query syntax like proximity search or fuzzy search. You can only search against certain fields, or you can boost more important fields. You can add synonym maps. So there's all this stuff you can do. But at the end of the day, there's still kind of a problem. And thinking about this problem, thinking about this query, how to cook French food, and think about these 4 kind of candidate books. If we kind of eyeball these and look at them, we're pretty quickly able to say, it's like, okay, Mastering the Art of French Cooking is the best match here. It's the only book here that's actually going to teach me about French cooking. But if we look at like the syntactic similarity, and this slide is kind of based off just kind of eyeballing the number of words in the book that match the query. Actually, this book has the worst syntactical relevance. because the only word in common with this book title and this query is the word French. Whereas how to cook everything, that has 3 matches. How to speak French has 3 matches. And actually, the best match is how to cook Italian food. Every word matches besides Italian. But I wanted to learn French food, learn how to cook French food. Maybe I'm already good at cooking Italian food. So we want to kind of go beyond this syntactic similarity and understand kind of semantically what is someone trying to find and how can we help them better retrieve that information. We really want to make this a much richer experience. And you're kind of thinking about this, if looking at this query, how to cook French food. There's these. If we think about all the syntactically similar tokens, so we're really searching the words how to cook French food, and then with language analyzers, the query will kind of be expanded to also search cooked and cooking, but there's also all these semantically similar concepts that we're really missing out on in our query, like introduction, learn, class, master, Paris, chef, and so on, that they really kind of illustrate what we're searching for, but they're not explicitly called out in our query. So based off of syntactic similarity, we're really not searching for them. But AI makes it possible to really kind of be able to compare information in this syntactic space, this is something I just think is super cool. I'm sure a lot of you are familiar with word embeddings, but I love with word embeddings, we're able to kind of map human language into this really high dimensional space, and you can actually do really cool stuff like kind of this math around it. So like king minus man plus woman, you should theoretically equal queen. You can actually pull down a Jupyter notebook and do stuff like this, which I still find mind blowing. And you go and beyond just kind of like the relationships between words like this. There's relationships between verb tenses, relationships between country and capital, and ideally a search service would be able to kind of intuit this and help us make give us kind of smart search results based off of this information and what's known about the human language. So with that, I'm super excited to announce the partnership between Microsoft Bing and Microsoft Azure to bring some of the best of Microsoft Bing to Azure Cognitive Search to truly enable semantic search. And what I think is really powerful here, if we think about Microsoft Bing, they've invested over 100 years of developer hours, millions of dollars just in compute time to train these models. The stuff they're doing is just so sophisticated. Actually, there's a blog post I'm going to link to in a second. You can see some of our research teams are very high up. We're even leading kind of these natural language leaderboards based on the research and the models they're building. So Bing has invested kind of tons and tons of resources into training these great language models. And so to be able to take advantage of them in Azure Cognitive Search is something that we're just kind of incredibly excited about, because there's just so much there. And so I'm going to dive into kind of some of the technical and what this means and how it works. But really, as far as a functionality perspective, what this really gives us is there's kind of 4 new pieces of functionality coming to search. So one, the first is semantic ranking. So we are we're going to take the results from the BM25, but also then re-rank them based off of the models provided by Bing, so that we can truly kind of promote and give you the best content first. There's also semantic answers, which is kind of what you're probably familiar with Google and Bing. When you type a question, what is the capital of France? You're kind of used to getting an instant answer. The capital of France is Paris, and with semantic answers, we're able to do just that. We also can do semantic captions now, which in search today, we can do hit highlighting for you, and we're highlighting based off of the terms you searched. But these semantic captions go a little bit beyond that. It's able to show you the most relevant part of the document, and then also kind of highlight kind of relevant words. You can see this case, Paris wasn't a word we searched, but we're still able to do hit highlighting on that word because it is incredibly relevant. And then kind of one of the last additions is the addition of spell check, which can really help to improve the recall of our queries. Even if we had misspelled France, we're able to leverage some spell check technology to kind of correct that, and then you pull out kind of exactly the content that we are looking for. And so there's actually this awesome blog post published a couple of days ago called "The Science Behind Semantic Search." This is published in like the Microsoft Research blog, and this is I'd say this is probably an incredibly fun rabbit hole to go down. The blog post kind of lists all this great information. There's even a video to go along with it, and then you can even kind of link into like the academic articles on some of these papers. So this is actually a visualization of like the unified LM model that's behind Bing currently. I won't dive into too many technical details. I just couldn't do it justice. But yeah, I would highly encourage you to check out this blog post. Yeah, I really enjoyed it myself. But I did want to share kind of a few high level details that I found kind of particularly interesting. So this is a screenshot or visualization of unified LM. And as recently as 2019, Bing was based on BERT, but since then we've switched over to using this unified LM model. And what I think what's awesome about it is it combines the strengths of auto-encoding models like Google's BERT, as well as auto-regressive models like OpenAI's GPT-2. So we really kind of infused kind of the best of these two kind of industry standards. But with that, these are kind of massive models that can have billions of parameters, and with that, billions of mathematical operations going on. So one thing the article talks about, I think, is just really cool, is this idea of distillation, where Microsoft Research has developed these state-of-the-art task-agnostic distillation techniques to compress these like massive pre-trained models into much smaller, faster ones, while kind of minimizing that performance loss. We're able to kind of distill all the knowledge from these massive models into much smaller ones that can then be executed much more quickly. So you take a model with billions of parameters and are distilling down to like a much smaller amount. And what this really allows is this allows you to run the models fast enough so they can meet the latency requirements of a search engine. And speaking of latency, we have all these models deployed on GPUs in Azure, so we can execute these models as quickly as possible. And then with the scale of Azure, we're also able to parallelize requests across multiple GPUs, so we can return results even more quickly. So that's about as deep as I'll go into kind of like some of the different models. What I want to do now is talk a bit more about how this actually works in practice. So you can see, in blue here, we have this level 1 BM25 ranker, and this is what exists today. So you have your content in the search index. You send a query, we find the matching terms, and then we send the results back to you via the API. But with the private preview, we're adding in spell correction, and what this is really doing is going to help improve the recall. Say, for example, like you were to search X-Men without the dash. You might miss out on all of the documents that talked about X-Men, where the dash wasn't. So the dash was included, so you were able to kind of further kind of improve the recall in that sense. Find any possible matching document, and then so then we're going to return you find the most relevant documents based off BM25, and then we're sending these documents to what we call this prep model, where we're preparing these documents to be able to be used for efficient ranking. Because you imagine if you had a 100-page PDF and we send all those thousands and thousands of words to a model, it might take that model a good bit of time to be able to kind of rank that properly with all that content. So we want to kind of simplify this down to a smaller document so that we're able to kind of more quickly rank it. And ultimately, we have this L2 or level 2 semantic ranker that will then re-rank these search results, so you can really find kind of the most relevant content very quickly. And so I guess looking at this kind of quite a slightly different way about kind of what's exactly going on is, so you send the query, we're going to do spell correction to improve that recall. We're going to do our lexical ranker, so we're pulling all the documents that have those matching tokens in the index. And then what we're going to do is we're going to return the top 50 documents. If we want to make sure we're pulling enough documents that we find the model has enough content, we can find really kind of the best documents from within those 50 and promote those up top in the search results. And what this prep stage really amounts to we're summarizing content. So maybe you have a bunch of fields or content with 1,000 words. We're going to summarize this down into kind of a single passage, so that we can then re-rank these documents, and then ultimately we're going to return them in the order kind of as they are ranked by this L2 model, which can then kind of drastically improve the relevance of these documents. And of course, kind of all these models here are deep neural networks, and we are accelerating them with a GPU just so we can execute and these as quickly as possible and really kind of save you on by minimizing that additional latency. So to give you kind of a real example, we spend kind of a lot of time kind of benchmarking and trying to make sure that we have more than just anecdotal evidence that this improves search results. So one kind of corpus out there is this MS Marco corpus so it's 3.2 million kind of documents of public corpus with a lot of kind of rich content from the internet. So if we take the query, when was Walmart started? We apply spell correction to that, and then actually looking through the results, the best document was actually document number 10. So you figure we're all a little bit impatient these days. We don't normally probably scan the first 5. So we might have even kind of missed this document or really had to search hard to find exactly where this was based off of the syntactic similarity. You figure there's a lot of documents that are going to talk about Walmart. So it might be hard to find kind of exactly that content we're looking for. But if we add in kind of these semantic steps where we are able to now use these models, we're able to kind of summarize and extract out the meaningful passage. We then re-rank this. We're able to kind of get this instant answer. So actually, now the top ranked document, which was number 10 before, does give us this answer we're looking for. And then with this highlighting and answers, we're able to kind of give that exact answer that Walmart was started in 1962 by Sam Walton in Bentonville, Arkansas. And so you can see here, kind of, if you think about this in the context of being kind of what I've been kind of showing you is it's very similar to kind of the experience you're used to. So we see when was a mental meta, which is a type of cheese. You get that instant answer. We get this semantic captioning where we didn't search 14th century, but it's still highlighted in our search results. We're kind of you're bringing the best of Bing now into cognitive search. You can have kind of this rich search experience. Like we're all used to from using these search engines. Before I dive into a demo, Sammy, any questions that you might have?
No questions at the moment.
Awesome. Well, let's go ahead and dive into a demo. I'm excited to show.
Yeah, I'm looking forward to see how it goes.
Perfect. So we have this demo, and what we've done is we've loaded in. There's a couple of different data sets in this demo, but what I'm showing you today is based on the COVID-19 data set, which is like this COVID-19 open research data set. It's a collection of scientific papers related to COVID. Many of you cognitive search fans out there, you might have seen that we had another kind of COVID demo leveraging kind of all like the enrichment time AI and some other cool kind of cognitive skills that we published earlier in the pandemic. But now we have an opportunity to kind of also try the same corpus against with semantic search. So practicing this demo, I started to have a bit of a sore throat. So you immediately in this day and age, like the only thing we can think is like, oh, maybe I have COVID. I'm a bit of a hypochondriac myself, so want to find out is the sore throat a common symptom of COVID-19? So I can go ahead and let's try to just ask the search service. So this is kind of a real Azure cognitive search service behind the scenes, leveraging semantic search. We've ingested all this content into the search service. So let's just start. How common is sore throat COVID-19 pages? You can see from practicing my search is already there. So let's go ahead and search that. And this right now is just we're not using we haven't turned on the semantic search functionality quite yet. Actually, I don't know. Let me just refresh this page real quick to make sure the search went through. Sorry, it looks like I need to just log in real quick.
Is this a demo the public can try out also, or it's private?
So as of right now, it is private. I do believe we're planning on opening up at some point. I'm not sure, but I think it's locked down currently. I think part of it, we just wanted to make sure that we didn't have too many people using it while we're doing kind of these Ignite demos. Yeah, we'll definitely let you know if it becomes public.
Totally understandable. The demo prompts are not always friendly.
Yeah. So here are the results based off of BM25. We can see we get results on sore throat, approaching a child with sore throat. I think if we scroll down a bit more, we do see here's like a sore throat and COVID-19 article. But generally, we're not finding exactly what we're looking for. Like, I really want to know, like, hey, like, what percentage of COVID patients have a sore throat? So we do is we can hit this gear icon, and we'll turn on semantic ranking and spelling, and you can see now that these results are reordered. You added that cool little animation in there, so you can see the effect. And I've actually you've clicked into this first document before, and I know if I kind of scroll down and look in the results section, that you have 1,773 patients studied. 11.3% had a sore throat. So it was able to kind of find exactly that document I was looking for. Although just looking at the search results, it still might have been a little bit difficult for me to know like this document had exactly what I was looking for. And so let's see if we can do kind of one better. Let's turn on semantic answers and captions, and we can see here now we kind of get these captions where we see your sore throat was 11.3%, 32.7. Actually, let me just make this search again real quick. You can see here now we have this instant answer promoted where 11.3% of cases had sore throat, and based on the study. We'd even kind of look further. In this case, it was 32.7%, 37%. So you can see like, with these semantic captions, just how rich kind of like the content you're able to see. Like, it went from kind of you're not having anything meaningful. Now I have kind of 4 different data points. So now I pretty much know 10 to 30% of COVID patients are going to have a sore throat. So pretty quickly I was able to find kind of exactly what I was looking for.
So by just adding the question mark, your results already changed?
I think that might have just been a thing with the demo where I just needed to get that answer to come back. It should work without the question mark, I believe.
Okay, all right. Okay, cool.
So maybe just a quirk of the demo, but you can see like it did still kind of give us this semantic caption. And one of these kind of cool is we could actually kind of compare these search results to kind of the standard BM25 search results. And you see kind of how different they are and how he was able to kind of find exactly what we were looking for. And I guess maybe Sammy, to kind of better answer your question too. So these are kind of like different like API parameters you're adding. So if you want answers, it's like a new parameter you'll add to the query, and I'll show that in just a minute. But I wanted to show you kind of a couple more searches as well. So one thing I remember kind of early on in COVID, there was some talk of like, hey, maybe we shouldn't be taking ibuprofen. It might make COVID worse in some cases. So let's go ahead and search the WHO recommendation on usage of ibuprofen. Go ahead and give this a search. And then you can see you were able to kind of get that answer. The WHO initially recommended against use of ibuprofen, but has since kind of revised this and states that both acetaminophen and ibuprofen may be used. You see some additional kind of content that will confirm that. Well, what's really interesting here, because we're looking at semantic similarity. When I type WHO, I could be referring to the World Health Organization, or I could be referring to just the word WHO, like as in like who is this? But because Bing has all this kind of rich content for all the searches and content in it, it's able to understand the difference between who, as in the World Health Organization, versus who is this person. To give another example, who was the first doctor to report COVID? You can see here I accidentally misspelled doctor, but that didn't really impact search results because we do have the speller turned on. As we see here, we were able to find Dr. Zhang Zhishgang. I'm sure I just butchered that pronunciation. Was considered the first doctor to report the novel coronavirus. But what I think is really interesting, if we compare these to kind of the BM25 results on their own, so there's probably no misspellings in our corpus of doctor. So for example, that word's not even kind of being considered in these initial search results. You can see these results are just kind of completely different than the one we're looking for. So you see just kind of how drastically this was able to kind of improve these search results. Any questions from you at this time, Sammy?
No. What I was wondering though, because you have who, is it then added as a synonym, or is it really within the semantic engine that it knows WHO or who?
Sure. So I think going back to is like the first thing we're doing is we are kind of sending all of these terms to the inverted index and using kind of BM25 as the level 1 ranker. So at this point we're going to return all words, whether or not it's any word that is the 3 letters WHO. We are kind of returning, and then kind of at that semantic L2 ranker, that's where we're going to have kind of this semantic understanding that hey, World Health Organization is different than just the word WHO. But we are going to start by recalling all of those from the that inverted index as a starting point.
Okay, cool.
So there's been already a few different customers who have used this. One of my favorite customers. I was actually a developer on this project in one of my previous roles a couple years ago. Howden came on stage, I think, a couple years ago to initially show this solution. But one of Howden's business problems is they make these massive compressors for use in industrial applications. They can be pretty complex and cost a whole lot of money. And one of the issues is that Howden actually had, they have compressors that were built quite a bit of time ago that are still up and running. And when they're kind of getting support questions or other type questions, they need to kind of be able to kind of quickly find the documents and be able to give meaningful answers to those customers in a short amount of time. So they spent all this, they've been building this for a while now. They were able to leverage kind of the AI at indexing time to enrich their content and build out the search experience. But the feedback we got from them was like, hey, this works great, like everything's going well. But we sometimes still don't kind of find that exact search result we look for. We might have to comb through the results and to find the right document. And you can do stuff such as adding in filters and stuff to kind of find what you're looking for. But they got the opportunity to try out semantic search, and immediately we got the feedback from them wow, this is kind of just the change that our system needed. To be able to help make be able to kind of promote that exact content. In this case, they have full text content or doing kind of longer queries, so it really kind of works well to promote the exact right content for them. And another cool scenario that actually is talked about in that blog post a bit that I mentioned is that so Azure Docs, which has kind of tons and tons of technical content used for all the different Azure products. They've been using Azure Search, and they've actually been using A/B testing and trying to really fine-tune their search index for a couple of years now. They've been running a bunch of experiments, kind of gradually trying to increase that click-through rate. But when they tried out semantic search, you would increase their click-through rate of the search result by 2% compared to their current production system, and 4.5% for longer queries, so queries that were 3 or more words. We will measure, you can kind of compare to their A/B testing, and those do sound like kind of small percentages, but trying to move a click-through rate is something that's very difficult. So this is kind of the single biggest increase in a click-through rate that Azure Docs saw. So it was super cool to see kind of internally a customer who was able to use this and improve those search results. You see kind of in this case how to use Azure Search. You can see all these kind of relevant, similar results that say they're talking about search, they're talking about Azure, but they're really not telling you how to use Azure Search. But when we add in kind of the semantic ranking, the first result is getting started with Azure Search using .NET. So we're able to kind of quickly find that correct document. So you can see for technical content scenarios like this, semantic search was just as powerful. So awesome to kind of see these testaments of your customers who are already using this. And like I mentioned, we have been working really hard to actually kind of measure these performance gains and verify them, and kind of look past just kind of like the anecdotal evidence of a query here or there working better. So with that, so this is currently a private preview. There will be a link on a future slide where you can go ahead and kind of request access to that. There should be a public preview coming in the next couple months. And one of the cool things is because you're just kind of adding query parameters, you can do some A/B testing to kind of compare the results. And one of the things I think is really awesome too is that re-ranking is all stateless today. Because you were still leveraging that BM25 ranking from the existing search index. You don't need to re-index your content. You can just really kind of add these query parameters in. And all of a sudden you're able to kind of leverage semantic search. So it's a pretty seamless process for adding this in and be able to improve these search results. I did just want to kind of quickly plug a few other things that we've working on. Semantic search is obviously kind of incredibly exciting. I wanted to spend the most time talking about it. But just a few other things. We commonly have customers ask us questions about performance, such as like, what size search service do I need to be able to handle 30 queries per second? So we actually put together a performance testing solution that leverages kind of JMeter, Terraform, and Azure DevOps. So you can kind of quickly get this up and running and kick off these DevOps tests. You can scale it out as much as you want with as many kind of these Azure container JMeter workers as possible. You can really kind of hammer your search service as much as possible. Like I was testing with like a fairly big S2 and sending kind of hundreds of queries per second. It's really a great way to do performance testing. And of course, we always recommend doing performance testing before going to production. And we do also have another kind of search plus Q&A accelerator. As you see, like, semantic search gives you access to these instant answers. We also worked on a collaboration with the Q&A Maker team, see how we could infuse Q&A Maker into search to also kind of provide these instant answers. You can see here kind of a similar scenario of me searching how to use fuzzy search, and we're able to get that instant answer back. And one thing that's kind of, I think, interesting about this solution accelerator compared to what I just showed you around semantic search is that in this case, you have full control of the questions and answers that are being returned. So maybe you have a customer support application, and you find your support agents are asking like the same 15 to 20 questions, and you really want to be able to fine tune the answers to those 15, 20 questions. So the support agents are able to kind of quickly deliver that response you're looking for. This type of approach using Q&A Maker gives you kind of that full control of the Q&A. And you're also able to kind of automatically extract that at indexing time. So definitely valuable in certain scenarios as well. And then finally, one of my personal favorites, something I worked on a lot myself, was this VS Code extension. Particularly if you ever find yourself kind of using Postman or interacting directly with the REST APIs, this VS Code extension will give you this rich IntelliSense, snippets, and all this little functionality to make it really easy to kind of edit and update your search indexes. You can add documents from here. You can actually write queries. We actually just added support, so you could send your semantic search queries from VS Code as well. So highly recommend checking that out. And just finally, some resources on what I shared today. aka.ms/semantic preview is how you request access to this private preview. We have a general knowledge mining solution accelerator. It's always a great way to get started with cognitive search. Provides you a great web app template and some other assets. There's a link to some other content that we've recently produced. And then, of course, please do feel free to contact us. We have this alias AzureSearch_contact@Microsoft.com that we're pretty good about replying to. So if you have questions for us or questions about semantic search, definitely don't hesitate to reach out. And with that, any questions that I can help to answer?
No, there are no more questions, but I still have some.
Sure.
So when you have your semantic search queries, would you still be able to combine them with the query syntax that you had without semantic, like to give specific words higher rankings in your search?
That's a good question. So I don't know if I have an example of so I'm not, to be honest with you, I'm not completely sure how those will interact with the semantic results. But so what I can tell you is when you issue a query like that, we're gonna give you like the raw search score, and then we're also gonna give you like the re-ranked score. So if nothing else, you'd be able to see that like the raw score was still higher for particular documents. But yeah, I'm not sure off the top of my head how those would interact together.
Yeah, like when you're searching for a specific thing and then that specific word cannot be in there. When you use the minus sign or the not to remove a specific word. So that might, that combination might not work anymore, or...
Well, so I believe that like in that case that should work for you, because you're going back to this, let me just click back to this diagram for us. So the first step of the ranking is you're sending this spell corrected query to the search index that exists today, and then retrieving the first 50 results. So if you explicitly told us you don't retrieve any documents that contain this word, they're not going to be a part of this top 50. So you'd still be able to kind of keep those out of your search results. Or yes, similarly, if you were to use this scoring profile, you can probably impact what these top 50 are going to be, and what will then ultimately be re-ranked.
Okay, cool. There's no more questions from the public, so I think it was a very interesting session, and it's really a product that you need to keep on watching all the things that are happening with it. It has been a bit silent for it with it. But lately, there's a lot of new stuff coming up with Azure Search, Cognitive Search. Sorry, rebranding.
With all the AI coming, we had to rebrand it to show off the
exactly.
Developments.
But actually, you should implement the semantic on the initial demo that Microsoft created, the JFK files.
It'd be cool. It'd be interesting to see how that would impact the impact.
Yeah, then you could actually ask who killed John F. Kennedy and see what it will answer.
That's true. Maybe we can finally solve the mystery.
Exactly. Who knows what would come out of it?
Definitely, it would be interesting.
Great, Derek. Thank you very much for your time for the very interesting talk. Not next week, but in 2 weeks, we have another talk by an ex-colleague of you, Derek. He was a cloud advocate at Microsoft, but now he's working for another company, Ari Bornstein. He was a cloud advocate. And we'll be talking about reproducible and production-ready deep learning. So really looking forward also to that talk. So 18th of March, same time, same place. I hope to see you all again. And with that, we say goodbye to all of you. We wish you a pleasant day, afternoon, evening, or morning, and we hope to see you all soon again. So, bye-bye.
Thanks, everyone. Bye-bye.
Hey, my name's Apansha Malik, and I'm from Melbourne.
Exit Sami with Val here.
Hi, I'm Alan Smith.
Hi, I'm Amy.
Hey, Semantic Test. I come from
I'm
Spain.
Prasant from California.
大家好，我是卢建辉。
I'm Nederlands. I'm Afghanistan from Australia.
Hi, I'm Jennifer Marsman from the United States.
Hi, I'm Arpita Gupta from India.
Hi, I'm Matthew Renton from the USA.
I'm Joe Spizak from California. Hi, Medin Eddie Daoud, Africana.
Hi, I'm Mana Famana.
Merhaba, ben Türkiye'den Daron Gönder.
Hi.
Hi.